Welcome to another DirectionsMag podcast, co-hosted with our friends at URISA.
Hello, Matt Garricky with URISA, and with me today are Jeremiah Grief and Sarah Klaas with the USGS, and with the United States Geological Survey. Their particular unit is the Elevation Operations section. So Jeremiah and Sarah, what exactly does the Elevation Operations section do?
Hi, Matt. We contract out people to collect LiDAR data across the nation, and our unit is responsible for looking over the data to make sure it's up to our USGS LiDAR base specification and any other standards it has to meet when the project is contracted out to begin with.
I was going to say that the second part of that is involves the publication of the data to the national map, and so that involves a few different products. It involves what we call the OPR, which is the original product resolution. That's what we get from the contractor. We package that up and distribute it for public availability. We also get the LiDAR point cloud, which is from the contractor, and we distribute that to the national map as well. And then we also, from the OPR data, the original point cloud that I mentioned earlier, we create a 1 meter product and a seamless raster product, which is our seamless nationwide coverage, and that's available in a 1/3 arc second or 1 arc second 1 degree block.
All right, excellent. So it sounds like your team has a lot to do with the topic that we're starting to dive into with today's podcast, which is data organization and data management. So as you start working with a contractor for a data deliverable, how do you start organizing it? What folders do you create to organize the project information, requirements, deliverables? Do you have naming conventions? Do you have a set system that you always use? How do you work with this to stay on top of the project and the task and keep everything straight?
Sure, Matt. I'm involved with a lot of that part of our workflow. So to begin with, the data providers, so we handle like big data. LiDAR is a lot of data as far as size. And so the contractors will send us, they break the data into tiles, so it's more manageable to ingest and review. They'll send us a tile index shape file that represents the extent of whatever data they're about to send us. And then we will assign that. We'll open it, look at it, and we will either assign it as what we call work unit, which is just their work unit is what we will assign to the one person to review, and how we just work through the data. These projects that we get in can be a half a state worth of data, or a whole state sometimes. So we have to break it into chunks that we as humans can manage and as our computers can manage. So that's called a work unit. We'll take these tile indexes, make a work unit out of them, or we might break it up into multiple work units. It depends on the size that they send us. The coordinate reference systems will be divided up. We don't mix the coordinate reference systems, and the quality level will also be divided up. So first we'll create the work unit, and then we enter that into a database that we call PTS, is Project Tracking System. And the whole center has access to this database so that they can look up and see the status of these work units. So after the work unit is created in the PTS database, We then also create it in our own operations database that we call Validate. So then after we create it in the PTS database, we will attribute the shapefile with a numerical code for the work unit and the overall project. This way, those codes, those are, you know, referenced in the database, but they can also be referenced in future queries to find this specific work unit within the project. And then we will create the record in our internal operations database, which is called Validate. And Validate automatically generates a standardized folder structure whenever we create the work unit within that. It's also linked to the PTS database, so they talk to each other. So all the information that we originally put into PTS gets imported into Validate. So everything's staying the same. You know, the numerical codes that go along with it, those all stay the same. The names stay exactly the same. And then we have our standardized folder structure with all the numbers and names used exactly how they're used in the databases. And once the data is delivered to us from the contractor, we download it into that folder structure that's already been made. So is this making sense so far? Any questions about that part?
So when you say you download it into the file structure, you know, what does that file structure look like? Do you have a folder for each work unit? Do you have subfolders within those different work units for the different pieces of data that you may receive from the contractor? You know, like the DTM or the original resolution DTM, or the LiDAR point cloud, or additional files or documentation. What does that sort of look like once you start putting that data into your file structure?
Yeah, sure. So first of all, the folder structure is by work unit. We have a standardized naming convention when we do create them and name them, and we use the state abbreviation, and then usually there's a name for the project, and then we'll give it a number, and then the year that it's collected. So an example would be like California would be CA and underscore wildfires underscore 1 underscore 2020. So that would be the work unit folder name. And then underneath that, we have 4 subfolders. There's Bare Earth, which contains the digital elevation model raster files and break lines. We have a metadata folder, which contains all of the contractor provided metadata and the USGS created metadata. We have an other folder, which is really just files that we don't need or files that aren't going to be published, we can put in there. And the point cloud folder, which only contains the LiDAR point cloud folder. And we have realized that the importance of having a standardized folder structure, we can automate so many more things. If the computer is making the folder structure for us, then we know it's all named exactly the same, uppercase, lowercase, all it's the same, and we can build our tools to query off of that standardized naming convention and standardized folder structure.
Yes, sir. I think that's a really, really important point there, because we have a bunch of validation tools that are that path to that folder is super critical for. And then not to mention, we have our Elevate software, which is the product generation software I mentioned earlier, and that's really reliant upon having that folder structure be standard and consistent, across all these work units that we're getting.
So you mentioned in the work unit folder, you have the year, and 4-digit year is always easy. One of the things that I've realized in my own work is that if we try to add months and days to the year to make a date, everybody does it a little bit differently, and so some folks are month, day, year, or year, or some folks are year, month, day. Do you run into any of those challenges, maybe with some of the specific files or metadata documents? And if so, how do you deal with those?
We don't use too many times where the date is used in the name of a file. The only part that we do use it in is the outputs that our tools make, our validation tools that Jeremiah mentioned. We will sometimes, so we validate the data, review the data, and if we find issues with it, we send it back to the contractor to get corrected. Once they correct it, they send it back to us. So we'll be running the same tools on the same work yet, like they'll have the same name because it's the same data. It's just a different version of the same area of data. And so with that case, we do append a date on the end of our tool output names, just so that you can tell, oh, I ran this tool in March, and then I ran this output is from July, so I know that this is the most recent version. I mean, I know they have like the date created stamp on the side of the file explorer thing also, but this way everyone just knows. And our outputs are all named the same way so that anyone can take over someone else's project, go in and look and know exactly what that is and when it was ran. We didn't used to do it that way. We would just kind of let people name it whatever they wanted. And we've really seen the benefit of keeping it standardized. I didn't really answer your original. We don't really use does product generation use dates on the end of the files? Like that?
We use some dates sometimes, like for the seamless product, for instance, when it was created, we timestamp a date when some of our product were created. But yeah, I'd say as far as like organizing our data, since we're such a big program, some of these projects span multiple years. We really just stick with the earliest collection date year for that. And then there's, along with the data comes a bunch of metadata, and we also have spatial metadata we provide with our products. So I mean, if people want more information, they can always dive into the details of it a little bit more. But just for our naming structure, we keep it simple. We just use earliest acquisition, start date. So whatever year that is.
So one of the trends that we're seeing in the industry is that as organizations move from network drives to hosted platforms like SharePoint, Google Drive, and even ArcGIS Online, but also AWS, Azure, and other larger cloud storage platforms, there's been an increase in metadata tags as a way to flatten traditional file structures while still making information findable and available. Is the elevation operations section using metadata tags as a way to help structure or organize their working data or the data that's published for public use? Or do you feel like you're still working with the more traditional way of managing data with folders and file structures?
Yeah, that's a really good question. We don't really do any metadata tags for internal organizations so much, but we absolutely create an XML metadata file for each of those products that I mentioned earlier. So, and those are used mostly for kind of an ingestion into Sciencebase, and we have a back-end inventory system that ingests that metadata and populates specific records in there, and then ultimately kind of shares that data with the national map. So the data people are downloading from the national map is kind of cataloged through that metadata in some respect. But as far as internal structure, I mean, we're using file folders, same as always.
Most of what we keep, like we have a SharePoint site for our group, but it's mostly just where we keep our meeting notes or our help sheets, reference things for our reviews. I think maybe a lot of other places would be able to keep all of their data on something like SharePoint or Google Drive, but our data is so large. We have all of our folder structure and our actual data holdings is kept on this massive storage servers. It's like petabytes of storage space.
Yeah, I don't know, Sarah. What would you say our average, one work unit is probably on average 500 gigabytes, or sometimes up to a terabyte.
Yeah, 2 terabytes, sometimes 4 terabytes.
Yeah, so these are massive amounts of data. It's hard to get away from the file folder structure.
So speaking of massively large data sets, regardless of how large or how small it is, it seems like backup strategies are something that everybody wants to consider. Because if you bring in data and you start working with it or reviewing it, the worst thing that could happen was for that your one copy of the data to disappear or be corrupted or not be available. So from the elevation operations section perspective, what does your backup strategy look like for all this data that's coming in that you're reviewing, or even more so, the final data products that you're pushing out to the public? Do you just rely on the IT section for that in terms of server or network drive backups, or is there something more conscious that your section does?
Yeah, that is definitely a concern of ours. We have had to track down data before, and it's never an easy task. We do have a few different methods of tackling this, and in general, we do, in the perfect world, rely on IT. We do have a dedicated IT department for the whole NGTOC, which is elevation, but it's also NHD and US Topo, and so they manage the whole organization. But I guess first off, if Sarah mentioned, we get the data from the contractors, so ultimately they always have a copy of that data as well. We also get the data on hard drive, so there's the potential we may have that data left on a hard drive after we bring it into onto our system. But IT also, they do snapshots every 2 weeks. So as long as data is within that 2-week time frame, we can back it up that way. And they also do some overall network backups periodically, but they're not as reliable, especially with these this large amount of data. I mean, it's not really feasible to back up 2 terabytes of for each work unit. I mean, we have hundreds of work units sometimes. That's nearly doubling or tripling your storage space. So we rely on those snapshots a lot. It's kind of a fail safe, and that's 2 weeks though. So we need to stay on top of things we change and really, if we find an issue, address it quickly, because there's a chance either we lose work or we have to go back to the contractor and say, oops, we lost the data. Can you send us another hard drive? And that adds time to the project. And our partners get mad at us. But yeah, I would say in general, we really do rely on IT to manage that. I guess I could talk a little bit about, so once the data is published, though, we actually do archive that data to a Glacier AWS cloud environment. So once the data is published, it's put into a cold storage environment where we can access it and restore it at any time. But
so the part that's backed up to the glacial cloud storage, is that a internal access only backup, or is the product that's pushed out and published also stored in that sort of architecture?
Yeah, so both actually. Yeah, so we archived the contractor provided data to an internal only storage, and then also our products that we create, the OPR, the LPC, 1 meter and seamless, those are all stored on AWS for public consumption, and that's all publicly available.
So given the size of your program and how much data you work with and the number of projects you have going on, names and structure is really important. So do you have any sort of change management procedure put into place so that if someone wanted to recommend a change with where these data are sitting, or how those data sets are managed, or how they're named, that there would be an opportunity to review that proposal and weigh the advantages and disadvantages of making a change to either your storage architecture or your naming and file structure?
I wouldn't say. Yeah, I wouldn't say externally, but we definitely have had those conversations internally quite a bit. And that's, if a change does get, pushed through, I mean, it's due to, us talking internally. Maybe it's a different type of product that we get, or, someone from another, I don't know. It's got to be pretty justifiable, and it's an internal process, I guess, would be my thoughts there. Sarah, I don't know if you were speaking.
Well, with stuff like the USGS LiDAR base specification, like stuff that is broader scope like that, there is an official way to submit proposed changes to that specification document. But like Jeremiah said, just for our internal folders, we just have meetings about it and talk about it for probably way too long.
Yeah, I'd say naming conventions are a pretty lively topic around the office.
It is.
I've often found that the larger the organization, or the more that data flows between different parts of an organization, the more that naming conventions and file structure and formats is the water cooler or coffee pot topic.
Yeah, no, absolutely.
One thing I found important, I guess, has been part of my role with this group, is documenting the changes, also like keeping really up to date and clear documents that our whole team can reference, because when there are changes, it's hard for a group to keep remember, oh, we're supposed to name it like this now, or whatever the change might be. So having good documentation and someone that makes sure that documentation is being kept up to date has been helpful, I think, for us.
Now, Sarah, thanks for bringing that up because that raises another question. You know, documentation on large projects is its own example of a folder or a file or a resource that needs to be managed in order for folks to know where it is and what it does and what the most recent version of that is. So could you talk a little bit about how you manage that documentation? Is there one version that's always the go-to that everybody knows is up to date? You know, kind of the living version of the document, so to speak. Do you keep past versions, archival versions of that for reference or documentation of what's been done before? And how do you track or juggle, you know, those different versions as they may change over time with your needs and the outcomes of those internal discussions?
Yeah, it can be a lot. In 2020, we did a lot of reorganizing as far as how we started reviewing our projects in a little different way. And so there were a lot of changes happening often with our standard operations procedure. So I maintain the SOP, the standard operations procedure document, which is really long. And I do keep previous versions. And in the current version, I have a little note on the title page, updated on this date, and then, you know, a short statement about what it was that updated. You know, XML metadata was updated on January 2020. So I keep a running list of what updates have been made to the document, but then I also keep the previous version. I haven't had to use the previous version yet, but they're there just in case. So everyone in the group as a whole is only accessing the current version. Sometimes I'll highlight the changes I've made in the new document. I'll highlight the part that has been updated.
Wow, we have talked through many different examples from a number of different perspectives. Do you have any final tips, tricks, or strategies to share about data organization and management?
You know, if I had any advice, it would be think about what you want your naming structure to be ahead of time. Think about what you want your folder structure to be ahead of time, and do whatever it takes and not to change that, right? I mean, keep that standard, because when you do change stuff, things definitely break. And you know, we've been a program for quite a while now. We've changed things, and you know, it's made the storage of data more difficult than it probably needed to be in a lot of cases. You know, I mean, so a lot of those changes were needed, right? I mean, as programs evolve, you know, they need to change, but I guess scrutinize those changes would be my advice. You know, especially naming structures. I think, you know, you can, and it's, you know, it's evident in our data. A lot of those early projects, like Sarah mentioned, were, you know, maybe not named the same, or as consistently. And when it comes to kind of, yeah, finding data, if it's not all consistent, especially over an 8-year program, it's you know, it has its challenges.
You know, like I said, we didn't used to spend as much energy on making sure everything was consistent. And now that we do, I can definitely say it's a benefit to the unit overall.
And then even, you know, even as simple as it sounds, just having some of those folder structures and naming conventions created automatically, and kind of eliminating, you know, the potential for user error. I mean, it happens, right? We all do it. You know, even if you do it over and over again, you're still at some point gonna gonna fat finger a letter, and it's gonna, it throws something off. So I mean, as simple as it sounds, just having that folder structure generated automatically, I think goes a long way. And we've seen it. I mean, in our workflow, we used to manually do it, and now our software does it for us, and I think we've seen benefits from that.
Well, thank you, Jeremiah, Sarah, and members of the USGS Elevation Operations section for joining us today to shed a little bit of light onto data organization and management strategies.